In this lesson, we shall solve this word problem in front of us. The number of dogs is twice the number of parrots, while the number of cats is one more than the number of parrots. Peter counted 46 legs in all. How many parrots, cats, and dogs are there, respectively? Right, so we proceed to solve this particular word problem step by step as follows. We present a solution to this word problem. So to present a solution to this word problem, we let x be equal to the number, right? The number of parrots. Y simultaneously becomes the number of cats. Z becomes the number of dogs, like so. The number of dogs is twice the number of parrots, right? So we look at the fact that we have the dogs, Z, and the parrots, X. But the number of dogs is twice, right, the number of parrots. So in other words, if the number of dogs, Z, is twice the number of parrots, then we need to put a 2 here, a factor 2, like so. Next point. While the number of cats is one more than the number of parrots, right? So the number of cats, we agree that we have Y cats, and we compare that with the number of the parrots, and you realize that the number of cats is one more than the number of parrots. And therefore, if it is one more, then we need to put x plus 1 here, okay? So we put here x plus 1, like so, because the number of the cats is one more than the number of parrots, right? Number of cats is one more than the number of parrots, and therefore if the cats are larger in number, then it means the parrots are smaller in number, and therefore to effect an equality, we put a 1 on the right, okay, on the side of the number of parrots. Okay. Now, moreover, we are told that Peter counted 46 legs in all. What is the meaning of this? Right, so if Peter counted 46 legs in all, it means that we need to remember that X is the number of parrots, and parrots are birds, and these birds have 2 legs each, right? And cats have 4 legs each. Right. Cats, which are Y, have 4 legs each. Dogs have also 4 legs each. And therefore, you have 4Z. And this is 46, which means, therefore, you have X plus twice Y plus twice Z equals 23. And this is one equation that we have here. Okay, a couple of things remain very, very pivotal. What are they? Right, we recall and we label our algebraic equations. This is the first, the second, and this one here is the third equation. That is how we label the equations. So we decided to put 1 and 2 right into equation 3, right? By doing so, we know very well that Z is twice X, but Y is X plus 1. So we actually will have Y is X plus 1, right? And we know that Z is twice X, right? So Z is twice X, like so. Okay. Now, this is what we have here, because we know that Z is twice x or double x, and this is the result, and the result is 23, which means therefore we have x plus twice x plus 2 plus 4x, and this is 23, right? So we therefore add all these here. We add x plus twice x, giving us 3x, right? 3x plus 4x gives us, they together give us 7x, right? So we write 7x plus what? Plus 2 equals 23, right? Plus 2 equals 23. We transpose the positive number 2 to the other side, getting a 23 minus 2, and that gives us a 21. Right, we furthermore perform algebraic division on both sides of the equality, and this effects and is called the cancellation law. We're cancelling 7, right, on the left, and if we divide, right, carefully dividing 21 by 7, we obtain the number 3. Okay, this is one step in the right direction, but there are a couple of things that remain very, very pivotal. What are they? We need to proceed to determine the numerical values of x and y, and therefore we proceed to say hence. What else do we know? We know that y is x plus 1. What is x? We have got x to be 3, which means in the place of the y, you have 3 plus 1, and 3 plus 1 equals a 4. All right. Moreover, we need to recall our z, right? And what is our z? Okay, our z is here, and it's twice x. So we put twice x for z, right? Twice x for z. What is x? 3, 2 by 3, 6. This is awesome news. It's awesome news. So what do we have here? Right, we're able to make the following conclusion. Thus, okay, because the question we had to answer has been to say, how many parrots, cats, and dogs are there respectively? Right, so to find the number of the parrots, we proceed as follows. Right, thus, they are, okay, they are x equals. Right, so they are x equals 3 parrots. Okay, 3 parrots. Y equals what? We got the numerical value of y. We got y equals 4. Y equals 4. And these are cats. Y equals 4 cats. And z. Right, z equals what? We got z, and we got z to be equal to 6. Right, and z equals 6 what? 6 dogs. Okay, we are in business, and this is the answer to the question. But a couple of things remain key, but very, very important for us to take into account. We need to proceed to check the accuracy of our solutions. Right, so we proceed to perform and to conduct a thorough check. How do we check the solutions here? Our solutions need to satisfy the equations. Right, we know that z is double x. That is one of the equations. And if we then say, so, right, this is the case. We know that z is that, but first things first, let us write down the solutions here so that we are in a position to check very carefully. Our x is 3, our y is 4, and our z is 6. Right, so z equals twice x is one of the equations, and we need to check this here. So to check this, we actually proceed to want to know if this equation is going to be satisfied by the solutions. Our z is 6 here, twice our x is 3, and we have that 6 indeed equals 6, and that confirms the fact that our solutions satisfy one of the equations, we proceed here accordingly. We have also one of the algebraic equations, y equals x plus 6, but y is a 4. Our x is a 3 plus 1, and this is 4 equals 4, and therefore this is the result as well. So 4 equals 4 is the result. Moreover, we have that at this point, we have the next algebraic equation. What is the algebraic equation that we have got? Okay, we remember the other algebraic equation, this one here. All right, we can even take it from here, okay, before the actual simplification, because we had these algebraic equations when Peter counted 46 legs in all. We divided by the number 2, both left and right, and this is what we got. But we can most effectively take this algebraic equation as it is and check if it is valid by the, or it is satisfied by the equations. So we have twice x plus 4y plus 4z, and the result is 46. Okay, what is our x? We got x to be 3. Our y became 4. Our z was obtained as 6. Let us check. Is this actually equal to 46? We want to know. Okay, so we multiply 2 by 3, we get a 6. We multiply 4 by 4, getting a 16, and 4 by 6, getting a 24. Is this indeed equal to 46? Right, so this is exactly 30 and 40, and we're getting a 46. Indeed, 46 equals 46. And we then say, Eureka, we have got it. But also, we have done it. And it is sufficient to then say, henceforth, right, so henceforth, we're able to say, right, so henceforth, you can say, henceforth, they are, okay, they are x equals, right, 3 parrots, right, simultaneously, y equals 4 cats, and, right, so we write down our z, and our z equals 6 dogs. And these are the figures we have got. We're excited, but very thrilled to have solved this word problem in front of us. And we got 3 parrots, 4 cats, and 6 dogs is the final answers to this word problem. Yeah, thank you so much for watching. What an awesome word problem, and a very, very goodbye to you.